Well, welcome to another video by Mrs. Delicath for the unit on perimeter area and volume. And although the Pythagorean theorem doesn't really have anything to do with perimeter area or volume, at some point in time you will need to know how to do it, and it just sort of fits in with all the formulas in this section. So we're going to be discussing what exactly the Pythagorean theorem is. So let me get rid of my picture and we'll move on to the next slide. Okay, so it says, the Greek philosopher Pythagoras discovered that in a right triangle, the lengths of the legs and the hypotenuse have a special relationship. And you should know already what the legs and the hypotenuse of a right triangle are, because you had to know that in your shapes, from your shapes unit. So remember, the legs form the L in a right triangle, and the hypotenuse, the longest word, is the longest side opposite the biggest angle. So the right angle in a right triangle is the largest angle. So basically his theorem, which is a theory that he proved to be true, says that if you square the lengths of the legs of the right triangle and you add them together, the result is the same as the square of the length of the hypotenuse. So we fondly call this a squared plus b squared equals c squared. And a and b are the lengths of the legs. Remember, those are the sides that form the L, and the hypotenuse c is the longest side. So the question is, how do you use this? Because it's all full of variables. So that's what we're going to discover. So we're going to move on to actually applying this. Okay, so you use the Pythagorean theorem not to find area, not to find perimeter, not to find volume, obviously not, because it's not a three-dimensional object, but to find the length of a missing side in a right triangle. Okay, so here's our example. Pretend like the legs of a right triangle measure 15 centimeters and 20 centimeters. The directions are to find the length of the hypotenuse. So remember, the hypotenuse is C. So that's what we're looking for, is C. So the C in this formula right here is going to stay a variable. And we're going to substitute in these two numbers, 15 and 20, for our two legs, because it says that the legs are 15 and 20. So let's change colors here, make it a little bit easier to see. Okay, so we're going to have the length of one of the legs, which is 15. And we're going to square that. And we're going to add that to the square of the other leg, which is 20. So we're going to square 20. And that's supposed to equal the square of the hypotenuse. Not the length of the hypotenuse, but the length of the hypotenuse squared. Okay? So we do as much as we can of this equation, and then we'll figure out how to figure out the answer. So 15 squared means 15 times 15, and 15 times 15 is 225. And we're going to add that to 20 squared, and 20 squared means 20 times 20, which is 400. And whatever that is supposed to equal c squared, the square of the hypotenuse. Okay, so we're getting closer to being able to find the answer, but we're not there yet, because now we can do 225 plus 400, which is 625. And that is going to equal the square of the hypotenuse. But I don't want to know what the square of the hypotenuse is. I want to know what c is. That's what we wrote up here. We don't want to know what c squared is. We want to know what c is. So what this means is that 625 equals whatever c is times itself. So to figure out what c itself is, if I know that there's some number times itself that has to equal 625, I'm going to take what we call the square root of that 625, which is written like this. The square root of 625. And I want to know what number times itself equals 625. And lucky you, you get to use a calculator to figure it out, but I just happen to know that the square root of 625 is 25. Oh, we're back down at the bottom again, so it doesn't really like me to write down at the bottom, so I have to do something different here. So that means that since the square root of 625 is 25, that means that C equals 25. And since this is the length of a side, the answer is 25 centimeters. So I'm going to put that in black right here so that we can see it really easily. 25 centimeters. Okay, that's how you find the length of the hypotenuse if the hypotenuse is the missing side. Okay, so now let's move on to our last example. And this time we're supposed to find the length of the missing side of the right triangle. And I gave you a picture instead of a description. Okay, so if you look at the picture, you will notice that I've given you one leg. And I know that because that's part of that L. Remember? That L that forms the legs. So this is a leg. I don't know what this one is, so I can either call that A or B. Doesn't make any difference which one it is. I'm going to call it A. And this is the hypotenuse because it's the longest side and it's across from the right angle. So I know that that is the hypotenuse. So this is C. And again, it doesn't matter if this is B or A, but we're going to call this one B just because I already called that one A. Okay, so remember our formula is A squared plus B squared equals C squared. Okay, so let's fill in what we know. We don't know what A is, so we'll leave A as it is. So A squared plus, we do know what B is, so we're going to substitute that in. I'm going to do it in a different color just because then you'll be able to see it better. So B is 36 inches, so 36 squared. Okay, and then we're going to say that equals, because remember A squared plus B squared equals C squared, and C is 60 inches, so we're going to do 60 squared. Okay, so now we're going to figure out the part of this that we already know. So A squared we still don't know. We're going to replace this with what it equals. And 636 equals, such a freaking idiot, I can't remember what I just did. Okay, so now comes the part that might be a little bit difficult for some people. We have to do some inverse operations because since we can't add 1296 to A squared, we're going to have to undo it. So we're going to subtract it on both sides. And so we're going to subtract 1296. So subtract 1296 on this side. And we're going to subtract 1296 on the other side, because remember, otherwise it won't stay balanced. What we do on one side, we have to do on the other side. I'm trying to conserve space a little bit here, because it doesn't like it when I write at the bottom. Oops. Okay, so if I subtract 1296 on both sides, then that means that A squared ends up being equal to 2304. And of course, you get to use a calculator to figure that out. I did this part mentally. And then, if you remember from the last problem, once we have A squared equal to 2304, our job isn't to find A squared. Our job is to figure out what A equals right here. And so we're going to figure out what A equals right there. Then we have to take the square root of 2304. And if you take the square root of 2304, and of course you can do that on your calculator, That means that A equals 48. And since this is just the length of one side, it's 48 inches. Hopefully that helped you figure out the length of a missing side of a right triangle using the Pythagorean theorem, which we lovingly call a squared plus b squared equals c squared. Good luck!